Hello students, this is lesson U2A05. In this lesson, we are going to be talking about different types of symmetry within a two-dimensional figure. All right, so first we're going to define what is symmetry in terms of a rigid motion. So we recognize something that has symmetry, just like with the symmetric property of algebra, that one side will equal to another. So the same thing could be said in a geometric sense, okay? A symmetry, a figure will have symmetry if a rigid motion can map the figure onto itself, okay? So immediately what comes to mind when we talk about symmetry, okay, in geometric figures, I immediately think of the human face, or I immediately think of things in nature, okay? So for instance, the human face has line of symmetry, right? Our left eye maps directly onto our right eye. Our right ear maps directly onto our left ear. Our left corner, the left corner of our lips will map directly onto the right corner of our lips, okay, and so forth. So certainly line symmetry is one of the classifications of symmetry. However, there are actually two types of symmetry, and we're not just going to be talking about line symmetry here, just because line symmetry immediately comes to mind. So here in this case, we have a butterfly, again, that has line symmetry. If we draw a vertical line right down the middle, that is an example of line symmetry. However, other examples of symmetries also exist in nature, and that is, in nature we also have rotational symmetry. So what exactly is a rotational symmetry? A rotational symmetry usually happens with things that are round, or things that have cyclical patterns, okay? So what are some examples of that occurring in nature? I immediately think of a sunflower. I think of flowers in general, okay? Or anything that is round, okay? Will have rotational symmetry. When we talk about rotational symmetry, okay, there are two things that we can talk about, one of which is called the order of symmetry. And when we talk about the order of symmetry, this is the number of times that a figure can map itself between 0 to 360 degrees. So if I look at this, okay, the sunflower looks like it's going to have many orders of symmetry, because we can rotate this in many increments, okay, and the sunflower will map onto itself. So the order of symmetry for the sunflower is going to be high, okay. We can also talk about the magnitude of symmetry. And what exactly is the magnitude of symmetry? It is the smallest degree that an object maps itself after a rotation. So for example, with the sunflower, would the magnitude of rotation be hot? Would it be a large angle, or would it be a small angle? If you're thinking that it will be a small angle, then you're absolutely right. All we got to do is just rotate this by a small degree, okay? And then the sunflower will be able to map onto itself. We can do this many times, okay? And that would be the order of symmetry, and the order of symmetry would be high. All right. So let's talk about this. What kind of symmetry does a regular hexagon have? And explain. Draw the lines of symmetry, if any, and the magnitude of rotational symmetry, if any. Determine the order of rotational symmetry, if any. All right, I'm going to ask you to pause the video for a moment and see for yourself what if there is any, okay? And as you can, so hopefully you had some time to think about this now. So how many lines of symmetry are there? Looking at this, I can see that there are more. There are actually 6, right? We can connect from corner to corner. We can connect from corner to corner, okay? And if we do connect from corner to corner, okay, we can have 3 lines going down. Whoops. We can have three lines connecting from corner to corner, and then we can have 3 lines bisecting each of the sides. So let me draw this really quickly because I'm not able to draw in the Google Slides there. So if I have a hexagon, the order of symmetry, or the lines of symmetry, will be 1, 2, 3, right? But then we also have 5, 6, I'm sorry, 1, 2, 3, 4, 5, and 6. 6 lines of symmetry. What exactly is the magnitude or magnitude of rotational symmetry? So if you look at this, the question is asking for, well, what is the angle measure to which we have to rotate this to get to the next point? So think about this for a moment. If you think the answer is 60 degrees, then you're absolutely right. We rotate this thing 60 degrees. Now, how do we come up with 60 degrees? So let's think about this. We rotate this. Look at the order of rotation. How many times we rotate this before it lands back to itself? Look at the animation. This can be rotated 6 times. 1, 2, 3, 4, 5, 6. Okay, it can be rotated 6 times. So because it can be rotated 6 times, and this, so we're going to divide 360 by 6, so therefore the magnitude must be 60 degrees. The order of rotation must be 6 times. Let's take a look at this. What kind of symmetry does this have? Draw the lines of symmetry, if any. And the magnitude of rotation of symmetry, the magnitude of rotational symmetry, and determine the order of rotational symmetry, if any. All right, so pause the video. Welcome back. So for line of symmetry, there are 2, because we can draw a vertical line right down the middle, and we can draw a horizontal line right down the middle. Those are our lines of symmetry. There are 2 of them. Now, what is the magnitude of rotation? If you look at this, notice that the H there, the top part is highlighted green. We rotate it once, twice, okay? The magnitude of rotation is going to be 180 degrees and another 180 degrees. So we have 180 degrees for the magnitude, and the order of rotation will be 2. So again, magnitude is 180 and the order is 2. And take a look at this. What kind of symmetry does a rectangle have? Explain. Draw the lines of symmetry, if any, to determine the order and magnitude of rotation. So pause the video and think about this for a moment. So the rectangle, I'm going to quickly draw the rectangle here, okay? So I have a rectangle like so, okay? And I immediately notice that I'm going to have a line of rotation here. I'm going to change color. I have a line of symmetry, another line of symmetry. Will the diagonals be? No, it won't, because if I fold the rectangle over its diagonal, the points on the rectangle will not land. So I have 2 lines of symmetry. So 2 lines of symmetry. Will this thing have, what is the order of symmetry? Well, it looks like if I rotate this, thing, okay, 180 degrees, right? It's going to land over here. So it looks like, okay, this is going to have an order or a magnitude of 180 degrees with an order of 2. All right, we have a parallelogram. Okay, so let's take a look. This parallelogram, and mind you, this is a parallelogram and not a rhombus. So we have a parallelogram. What exactly will be the lines of symmetry? Now, looking at this, it looks like the lines of symmetry would be, we can have a line of symmetry. It looks like there will not be any lines of symmetry, because if I fold over any direction, it's not going to land on itself. So there is no line of symmetry here. Will there be any orders of, will there be any magnitude or order of rotational symmetry happening here? It looks like there is a rotational symmetry. We can rotate this thing and it will land right there. Okay, so it's going to be 180 degrees. and the rotationals and the magnitude, the order will be 2 then. So there's no lines of symmetry. However, the rotational symmetry would be not 360 here, so I got that wrong. This should say 180. And then here it should be 2. Okay. And that's it.